We're now ready to check out our windowing sub-VI to ensure that it behaves as it should, and in addition, I hope to convince you the reason and motivation behind the windowing function and show you the problem that does exist if you choose not to window your OFDM symbols. All I've done here is taken our symbol to FFT and cyclic prefix blocks that we've created previously and input the necessary data to produce two complex baseband OFDM symbols with different pseudo-random noise so that usually there'll be some sort of discontinuity between the two of them. Once I've done that, I've run them both into a windowing function with the same user control, the ring menu that we created earlier, and then I've concatenated the two arrays and then output the real and imaginary part because again in general we're not going to have Hermitian symmetry and we will have a complex baseband OFDM symbol. And if this worries you at all, remember we're going to be modulating the real part with the cosine of our carrier and the imaginary part with the sine of our carrier. Let's go ahead and look at the example we've set up, and the while loop was there in case you were wondering, just so we can change the windows in real time and watch how it affects the data. So first let's look at the unwindowed data and see if there is indeed a problem. And as expected, we do have a discontinuity both in the real and imaginary part of our signal, and this will cause excess bandwidth when we go to transmit the signal. And this is exactly the problem that we're trying to alleviate by windowing. So let's go ahead and choose a window. A common one is the Hamming window, and you can see the discontinuity is driven towards 0 in both cases. Now there is a trade-off here, and you should be able to see it pretty soon when we zoom out at how much the shape of the signal has changed. Remember that when we multiply by a window in the time domain, we are in fact performing convolution in the frequency domain, and so there is a trade-off between removing these discontinuities and introducing some distortion in our frequency domain and thereby potentially altering our data. So it's important to realize the trade-offs and do some testing with different windows and see what's appropriate for your channel before committing to any kind of action that's going to ruin your data. So that's all there is to it. It looks like it works. If you have any questions, I encourage you to check out the CNX module or email the author.